Hi everyone, in this video lesson we are going to speak about spanning tree protocol as an element of a redundant network. First of all, let's take a look for the redundant components in the local area network. So the redundancy is actually the backup pass from point A to point B. Now let's take a look for the element of redundant in communication between PC1 and PC4, where PC1 is using the pass from S2 to S1 because it is the best way currently. And in case if something wrong will be with the link between S2 and S1, our communication will be still be happening through S2, S3, and S1. It is not the best way, but it is actually much better than nothing because we are not able to communicate with the link between S2 and S1. And if our link will be recovered, then our communication can be happening again through the same best path, and now everything is okay. So this is how redundant component can help us in the communication, can help and save our packages, our frames. But at the same time, uh, the redundant component can provide you some issues like the MAC database instability. So let's take a look for an example where PC1 is communicating with PC, is actually sending the broadcast, and when this broadcast is resent by the switch 2, it is resent. So look, switch 2 knows about PC1's MAC address through FA011's port, and after this broadcast come back again, and now switch 2 think about PC1 as through interface F01. And every time this broadcast will be continuously resent between switches, and all the time this MAC address uh, information will be updated one more time. Also, another big issue is the broadcast storm. So let's take a look for the same scenario where PC1 is sending the broadcast and two switches are receiving them, and afterward they resend these broadcast messages, and one more time they will resend these messages until that moment when our network will be damaged. So we don't have an element which is protecting uh, endless loop in layer 2, like in layer 3 it was the TTL, and as the result our network will be damaged fully, and we will not be able to communicate through the network. So this is another issue when you are using the redundancy in your network. And another problem which can be faced by us is the duplicated unicast frame. So let's take a look for the communication between PC1 and PC4, and this is unicast communication, and our switch to think about PC4 that it is connected through FA02 and FA01 ports. By the way, at the beginning, switch 2 doesn't know about which port is bounded to PC4 due to the fact that in its table there was no such kind of information, and as you remember, a switch propagates the broadcast communication, and as the result, PC4 will get twice the same message, and this is called a duplicate unicast frame issue. And now let's take a look for the STP operation. So actually what STP provides us, the spanning tree protocol. The spanning tree protocol is providing us the services which is preventing those three issues which we described with you just a few minutes ago. And now let's take a look. So STP actually blocks one port, which is giving us ability to finish or to prevent the endless loop, and the broadcast which is coming from S2 to S1, from S1 to S3 will come back again to S2, but S2 will block this communication. So, and then we don't have loop. Alright, How STP compensates for the network failure? So let's take a look for this example. In case when we'll have a network failure on our main link, then STP will will unblock the blocked port so that we'll be able to communicate through it normally. And then switch once port FA01 in this example is now blocked, and this port now is responsible for finishing this endless loop. STP conversion steps. How STP works and how it is possible that STP selects one port which will be blocked in such kind of topology. First of all, STP protocol elect a root bridge, and the root bridge is like a central switch according to which all of other switches will calculate the port statuses, and at the end the worst calculated port will be blocked actually. After what, and let's take a look for this step. STP algorithm. STP algorithm, spanning tree algorithm, is actually called the STA, in which we will have with you STA, and STA designate a single switch as the root bridge, as a central switch, and all other switches are calculating the path through it. Well, STA algorithm generates the protocol data unit, BPDU, and inside this BPDU packet there is very important information which is called BID, bridge ID, whereas bridge ID consists of priority value, the MAC address, and optional extended system ID. It's actually the ID of the VLAN if you are using the PVST protocol. It is actual Cisco proprietary protocol. Currently, let's take a look only for the priority, bridge priority, and the MAC address table. So bridge priority is used by switches to identify a root bridge by lowest priority value. And if you'll take a look for such kind of example, where switch 3 and switch 2 have the priority value 32,769, and so they are the same, look, and priority value of switch 1 is equal to 24,577, and all of the switches starts to create the spatial packages which are called BPDU, bridge protocol data unit, and BPDU from this side and BPDU from this side. And switch 1 generates BPDU with these values, and switch 3 thinks that it is the root bridge actually, and it is propagating this communication to its neighbors, and neighbors also propagates their own BPDUs to their neighbors, and switch 2 also do the same job, and at the end they are making comparison of that whose bridge priority BID value is lower, then that switch is going to be elected as the center, as the king switch. It doesn't mean that this switch is much faster or much newer or so on. It can be just configured like this, and it can be actually the worst switch in the network. But with the priority value, it is possible to become, for switch 1 to be the king, to be the center, to be the root bridge. So Cisco default priority values are equal to 32,768 actually, and from where we get this 9 is actually +1, whereas 1 is the value of default VLAN. All of the switches by default are working on the VLAN 1, and that is why we have as a result 32769 default value of our priority of the BID. But in fact, the priority value is 32,768 plus its default VLAN value. And the lowest priority provides ability to switch 1 to become the root bridge. And priority value can be changed by using this command. In global configuration mode of the switch, you can just write spanning tree, afterward defining the VLAN, and after defining the VLAN you will just define the priority value like 24,576. So you configure it as the 6, but as a result you get 7 because you have +1 to this value. Alright, let's take a look for another example in which you are able to see that all of the priorities are the same, and due to that fact that we are not able to distinguish switches by the priority values, then switches are using the MAC address of each of them to identify which switch is going to be the root bridge. And in this case, root bridge is going to be elected as the switch 2. Why? Because it has the lowest MAC address value, like they have 000A, 00, and the first one in a row is distinguishing that it is the best one. And now switch 2 is becoming the root bridge, and you see here it is 3, and you see here it is 2. So BID is equal to priority value of the root bridge of the root bridge and the MAC address. So root bridge is the switch with the lowest BID value. Let's take a look for a review of the BID. The priority value is used by switch to identify root bridge by the lowest priority value. Priority value values for Cisco switches are same by default. It is 32,768, but you don't have to remember that it will be shown to you as a 32,769, and you have to know from where you have this one. It is actually VLAN ID, which is used by default. If you'll use another VLAN, then another VLAN's value will be added to the priority value. So, well, priority value can be changed by using global configuration command like spanning tree, VLAN ID, and priority and its value. And very important thing that in the Cisco switches, priority values, the step to change the priority value is 4096. So you can, for example, define priority value as 0. The next available value for you is the 4096. Next available value is 8100 and just a moment, 82, 182. So and so on. And next value will be 16,000 and something, and next value will be sorry, not 16,000, it will be 12,000 and like this and so on. Okay. If priority values are same, then MAC address are used to identify the root bridge. The lowest MAC address will give the best result. Second step of the convergence of the STP, after electing the root bridge, switches elects the root ports. How they are making this calculations? Also, SCA defines switch ports roles as the root port, designated port, and non-designated port. And actually, so let's take a look from the root port. What are the root ports? When we elected the root bridge, all other switches, non-root bridge switches, are calculating the best path for the root bridge. And in this example, switch 1, switch 3 and switch 2 defines that FA01 here and FA01 here are going to be the root ports. Why they are called root ports? Because they are much closer than other ports to the switch 1. And as you see, direct communication from them. Okay, that is why they are called root port. But how the best path is calculated, we'll take a look with you from this slide. So we have the path cost to the root bridge, and here is the table which is defining the speeds of interconnectivity between switches and the cost, revised cost, and this was the previous cost. You will just forget about this cost values because you just need to spend your time and attention only for this values. And now in case when you have a 1 gigabit per second communication between switches, then the cost value will be 4. For example, you have S1 which is connected to, let us say, to S2, and we have also S3, and let us say switch 2 is going to be the root bridge, and switch 2 is the root bridge, and switch 1 and switch 3 are calculating the best costs for the root bridge. And imagine that the speed between them is everywhere is the fastest Ethernet, or we may say 100 megabits per second. And due to that fact that our speeds are 100 megabits per second, we are able to identify which cost will be equal to from switch 1 to S2 by using this link. It's actually is going to be 19. But in case if switch 1 will try to calculate the pass through the switch 3, then we have 19 value here and 19 value here. So the pass from switch 1 to switch 2 is going to be just only 19, and the pass through S3 is going to give us 38. That is why switch 1 will say that, oh, okay, this port is the root port, and it will not be blocked due to that fact that it's calculating with the root bridge. Another situation, so let's take a look for another situation. And by the way, before speaking about another situation, let's take a look for the spanning tree cost comment, which can be used to configure our interface, so that you can just say, look, this is your cost, and you will not calculate it by yourself. To take a look for the best path, to verify the best path, you are able to write the comment show spanning tree, which will show you the cost for the root bridge, and actually cost will be shown also here. And in this example, in the example of communicating between, so let us say switch 2 and switch 1, where the switch 1 is the root bridge, and then our switch 2 is connected by two links which are absolutely which is giving you absolute same cost. So 19 here and here, because we have here fast Ethernet and fast Ethernet, and 19 also here and here, fast Ethernet and fast Ethernet. So then switch 2 has question, who will be from these two ports will be the root port. And afterward, it is looking for the costs. Cost from here is 38, and cost by using this pass is also 38. Then switch 2 will use the priority value of each of the port. The priority values are from 0 to 240, and if you didn't configure anything on your switch, then the priority values are going to be 128 by default. So this is default priority value. And due to that fact that priority values are same, then we also have the question how to select the root bridge. But in case if you already configured your port with the common spanning tree port priority, and for example you will decrement it up to 112, then of course FA01 will become the root port. Here it is. And if they are, so look, if priority values are same, then switch use the port ID, which is just the sequence number of the port. And let's take a look for an example by using this value. So look, this is our priority ID of each of the port priority. These are our costs. And let's take a look for the next value, which is actually showing us, just a moment, this one, .1 and .2. This one came from just the sequence number of our port FA01, and FA02, which is giving us the priority of the the sequence number of the port in the priority of the port actually. So the priority of the port, and here we have the number of our interface. So that is why FA01 is elected as the root port, and it is working. Well, and another step is that STP or STA spanning tree algorithm is electing a designated or a non-designated ports, whereas designated port is the port which is working and which is not blocked, and non-designated is actually the port which is in blocking state. How to define the port role? This is defined by the port priority value or by MAC address value. Now let's take a look for the how. Let's make a review of how switches are defining their port roles. And in case if switch 1 is the root bridge, then by the way, I forget to tell you about that all ports of the root bridge are going to be will have the port status as the designated. Their ports will be always in the working state. Another stuff is that afterward other switches are making calculation of the best path to the root bridge, and in this example switch 3 and switch 2 are defining their ports FA01 as the root bridge because they are much closer than different variants. And afterward we have a question: who will become a blocking port? Switch 2's or switch 3rd port of FA02, and they are exchanging the BPDUs, and inside their BPDUs they have the priority of the ports, and also they have the MAC addresses. And from here we may find out that switch 3 is becoming switch 3's port of FA02 is becoming the non-designated port or the blocking port because its value, its MAC address value and its bridge ID, as you see here, so bridge IDs are absolutely same, and MAC addresses are same till this moment, and after what we have differences from here, and from here. So that MAC address which is lower will give the priority for our port, so that our port FA02 will have status of designated port and it will work. But this port is blocked. It is blocked and it will not be able to forward data. And this is how STP defines the the root bridge, and it is defining the priorities of the ports. Switch port states. So we have different states of the switch ports. They are blocking, listening, learning, forwarding, and just disabling. And actually, this state is not in the state of the STP. This is not STP state because disabled is actually the port which is shut it down. Shut it down port, which is administratively shut it down, will be in disabling mode. Well, the blocking port is a non-designated port and doesn't participate in the frame forwarding. The port receives BPDUs to determine the location and the root ID of the root bridge. And it is not propagating BPDUs by itself, it is just only receiving BPDUs and is not sending or receiving any data frames. Whereas listening port status has determined, STP has determined that the port can participate in the frame forwarding according to the BPDUs that switch has received thus far. And at this point, the switch port is only receiving BPDU frames and is also transmitting its own BPDU frames to inform adjacent switches, like neighbor switches, that the switch port is preparing to participate in active topology. And during the listening state, all what port is doing is just receiving and sending BPDUs, and it's not participating in data forwarding yet. Whereas learning state is the port prepares to participate in frame forwarding and begins to populate the MAC address table. What does it mean, the populate MAC address table? The switch is actually waiting for 15 seconds so that if someone will start to make communication, switch will generate its MAC address table, and during this learning process, switch is not able also to receive and to forward the data frames. And the forwarding state is of the switch port is actually that state which is fully working state, and at that moment switch is sending and receiving BPDU packages, and also switch is sending and receiving data frames at the same time. And disabling port is actually, as I mentioned before, is not STP port status. It is just the port which is administratively shut it down. So, and if we'll take a look for the port functionality, where we have different port status like blocking, listening, learning, forwarding, and disable, we may find with you that the blocking port is just receiving only BPDUs and nothing. Whereas listening port also receives the BPDUs, and this is just learning for the MAC addresses, and learning I'm sorry, it's not learning MAC addresses, it is receiving BPDUs and it is sending BPDUs. And whereas learning state of the switch port is receiving the BPDUs, sending BPDUs, and learns for the MAC addresses of the end devices. And the forwarding state of the switch port is doing everything. It is receiving BPDUs, it is sending BPDUs, it is receiving data frames and it is sending data frames, and also at the same time it is learning for the MAC address tables, for the MAC addresses. And disabled state of the switch port is actually just is not working. It's turned off port. And we may take a look for the BPDU fields, and we have actually 3 by 4 fields. The fields from 1 to 4 are identifying the protocol ID, the version of the protocol, the message type, what type of the message it is, and the flags. Whereas fields from 5 to 8 are defining the information about the STP, including root ID, cost path, and breach ID, and the port ID. And fields from 9 to 12 defines the message age, the max age, the hello time, and the forward delay. And actually the last 4 fields are just defining the timers. And if you'll take a look for the picture from the right side, it is actually the snapshot from the Wireshark. I'm sorry, not snapshot, screenshot from the Wireshark, which is showing as the spanning tree protocol communication, and which is showing as you see, the flux, the type of the PBDU, and also the pass cost, and we have the timer fields. Everything which is defined from here is actually can be seen in the Wireshark in the real packet analyzer. Alright, so we have the extended system ID in BID. So actually we have different types of the spanning tree protocols. So STP is the standard spanning tree protocol, and the PVST plus per VLAN spanning tree is the Cisco proprietary protocol, and their BIDs are quite different. So whereas in STP we have breach ID BID, which is equal to 8 bytes, and BID of the PVST plus is also 8 bytes. Okay, but the differences between them, like in STP breach ID was only 2 bytes. Okay, the only breach ID was 2 bytes, and in PVST plus breach ID and extended system also has so both of them get 2 bytes. But look, previously it was 2 bytes for, or we may say 16 bits for the breach ID, but currently we have only 4 bits for the breach ID. And how it is possible to cover the same range of the maximum value of the breach priority, where we have the breach priority from 0 till 6500 and 535, and here we have also from 0 till 65 and 535. How it is possible? Well, in STP we are able to configure the breach priority values like 0, you can provide 2, 3, and 4, and so on, and up to 65 and 535 value. You can just provide these configurations. But in the Cisco proprietary protocol, you are able to provide only values like 0, 4096, 8182, and 12,000 and something. And step of incrementing the priority values is just 4096. Okay, this is one step. But here we had step it was just 1. And due to that fact that now we have our step 4096, we have less amount of the less amount of combinations, and starting from 0 up to this value, now we have just only 16 combinations because we have the values like so this is first combination. It is defining 0, just 0. The second combination, it is defining value like 4090, 96. And next value, it is defining the value of 8182 and so on. So the last value will define 65,000 and like this. So that is why we are able to use the same range actually of the configuration of the bridge priority, but this range is just has less combinations, and all other part, I mean 12 bits, rest 12 bits used to define the extended system ID. There's actually the VLAN ID. Okay, so that we are able to define it like 2 to the power of 12, which will give us the value of, so let's calculate it, 2 to the power of 12, 9,000 and 4,096. So many VLAN IDs we are able to define in this range. And afterward, the last subfield of the BID is equal to the MAC address, and it actually takes 6 bytes or 48 bits. Well, let's take a look now for the BPDU timers, or we have hello time, forward delay, and maximum age. Whereas hello time is the 2 seconds by default, but it can be configured from 1 to 10 seconds. It means that STP protocol is sending each time, I mean every 2 seconds by default. In the period of time of 2 seconds, they are sending to each other the hello packages. This hello packages is very small amount of data, and is just used to identify is the neighbor is still working or not. And in case when the neighbor will not receive 3 hello messages, or after 6 seconds from the last hello message, our switch will think that the neighboring switch is going down. And afterward, we have the forward delay time. Is actually forward delay time is time spent in the listening and learning state. This is by default is equal to 15 seconds for each state. So look for each state, but can be tuned between 4 and 30 seconds. And it means that switch is waiting for the 30 seconds and spending this time for listening and learning states. Okay, it means that switch port is not able to normal operation. And the maximum age, the max age timer controls the maximum length of the time a switch port saves the configuration of the BBDU information. By default, it is 20 seconds. Okay, but can be tuned from 6 to 40 seconds. And now let's take a look for the algorithm of how these timers are using. And so look, blocking state, loss of the BBDUs detected, and maximum age is the 20 seconds. After this maximum age is expired, our switch goes to the listening state, and in listening state, this the forward delay is 15 seconds, and after the listening state, a learning state become to work, and it is taking 15 seconds. And after 15 seconds, our switch port will be able to work. So fully, these timers are taking for about 50 seconds of delay of the communication of the functionality of the switch port. It means that if your switch port is just connected to PC, for example, not on the switch, or maybe also to the switch, this is switch 1 and switch 2, their ports will not work for about 50 seconds due to the fact that they will wait for these timers, and it's actually the best practice to have such kind of big delay like a 50 seconds. 50 seconds is almost 1 minute. And now let's take a look for the types of the STP, starting from the STP, which is just the CST, can be called as a CST. It is actually the common spanning tree, which we spoke about before in this lesson. And also we have the PVST plus, it's Cisco proprietary protocol, which is just enhanced protocol of the STP, which can also provide the additional functionality of that switch can work with the multiple spanning trees according to the usage of the different VLANs, like a VLAN based STP. That is why it's called actually per VLAN STP. And in 2004, STP is a little bit changed. It still has the format of 802.1d. It's just update the STP standard. Also, we have the protocol 802.1w, which is actually RSTP protocol, which is working much faster. Its convergence is much faster than the convergence of the just the basic STP, because its timers are enhanced, and actually it has a little bit different algorithm of the work. And also we have the rapid PVST, which is familiar with the RSTP, which is per VLAN STP, which has enhancement of the speed of the convergence. And MSTP, multiple VLAN STP, which is also the standard STP, and which can provide a separate STP for multiple VLANs. So it is quite different than the PVST, because PVST creates a different table for the separate single VLANs, but MSTP is creating separate STP tables for multiple VLANs. It's like using like a set of the VLANs. Now let's take a look for the comparison between them, where we have enabled the protocol, STP, PVST, and so on. And we have the standard. Is it standard protocol, or maybe it is Cisco proprietary protocol? And let's take a look. STP is the standard protocol, which has the IEEE standardization 802.1d. PVST is Cisco proprietary, RSTP 802.1w. And rapid PVST is also Cisco proprietary. And whereas MSTP has two variants, or 802.1s or Cisco protocol. Resource needed. How much resource needed for usage of these protocols? STP use very low resources, because it is actually it has very slow convergence, and due to that fact that it has very slow convergence, it doesn't need to have extra calculations to be done or extra messages to be sent. And also according to the tree calculations, all VLANs, it is calculating the tree for all VLAN at the same time. And PVST is Cisco proprietary protocol. It is required to have much more resources, because it is creating the different spanning tree tables for different VLANs. So if you have 10 VLANs, you can use you can use 10 spanning tree tables. And convergence is also slow, and it is creating the calculation per VLAN. That is why it's actually taking the higher resources needed. whereas RSTP is 802.1W standard, which is using medium resources. Actually, it is okay. It's medium. It's high, and we can say medium, and it is calculating additional passes like backup passes, and it is calling the ports not blocking but alternate ports, so that when port is in blocking state like in basic STP, after the normal link will be damaged, the blocking port will not immediately start to work because it has to recalculate all the passes to the root bridge, and it will take long time. But in RSTP, switch will make calculation before it will place the port to the alternate or the backup port state, and that is why it is taking more resources, and its convergence is fast because when the link will be damaged, our not blocking but alternate or backup port will immediately be placed into the forwarding state, which will work with the BPDUs and which will work with the data frames immediately. And it is like an STP also make all the VLANs calculation. Whereas rapid PVST is the alternative for the RSTP. It is taking very high resources, which is needed for it because it is making per VLAN calculation, and it's also making the calculation for the backup port or for the alternate port. And whereas MSTP is the working, it's taking also high calculation resources because it is making calculation for the multiple VLANs, for the sets of the VLANs, and 3 calculation per instance. For example, you can create a separate STP tree for VLAN for VLANs 10, 20, and 30, and another tree you can create for VLANs 40, 50, and 60, and they will have different tables. Okay, where in comparison, like in PVST, you'll create different tables for VLAN 10, another table for VLAN 20, and another table for VLAN 30, and so on. It will create much more. It can create much more tables due to the fact that this protocol is calculating per VLAN, not for the sets of VLANs. And now let's take a look for the PVST description, so how it is working. Actually, we can create such kind of topology in which we'll have two root bridges. We'll have two root bridges switches, but both of them will work for different VLANs. And we'll have with you trunk, and as you know, in trunk we have the information from different VLANs. And actually, let me show you the demo in which we will have with you, first of all, we'll have with you an example with the basic STP. So let me delete these values and this value, and let me name my switches as so the display name will be S1 and host name will be S1 also. This guy is going to be configured as S2 and S2, and the last one is going to be configured as S3 and S3. Now, as you see, we have one port which is which has the color of the orange, and you may think why it is orange. It has to work with the green because the port is actually physically turned on, so you can even check with the command like a show interface FA02, and it will show you that the port is up and disconnected. Or if you'll take a look for this ports from the command show IP interface brief, you will also see that this port FA02 is turned on. The protocol is up, but but it is just with different color. It is orange. If you don't know about STP protocol, then you can have such kind of questions. But due to that fact that we know what is the STP, we can just think about it as in the blocking state port. So now let's take a look for the status of each of the switches. So we'll just take a look for the status of switch 1. Like this. And to see the status of the switch 1, the spanning tree protocol, we have to type show spanning tree, which will show us that switch 1 root ID. So this is a root bridge ID. I mean, its priority is 32769, and the address of the root bridge is this one. So let me open it in bigger window like this. So, and here we have information. This is root, and actually it means that switch 1 right now is the root bridge. And from this report table, we may find out what is the root ID, what's the priority value of the root bridge, and what is the MAC address of the root bridge. So let me just copy this value and let me place it here. So we know that root bridge is the switch 1, and now I'll just place here its MAC address table. MAC address which is used by the switch, and now let me type here the priority value which is used here. The priority is oh, sorry, not 23 but 32769. So did I write correct one? Yeah. And we may see that our ports roles are designated, and as you remember, every root port, every port of the root bridge is defined as designated port. So let me just define here them with D values. D is the designated port, okay? And now, and you may see that bridge ID. So bridge ID is actually that ID which is sent by our switch, and the root ID is actually root bridges priority and addresses and everything else. And you may see that the root ID is equal to the bridge ID. Why they are same? Because that information which was sent is equal to the root bridge. That means that our switch is the root bridge. But you also may see here this value. This is the root. Let's take a look for the status of switch 2. We'll just write command show spanning tree, and we may find out here that switch 2. Here we see root ID which is same, because we see the MAC address of our root bridge. So it is this one. Our switch knows who is the root bridge, but here we don't have this value. This is the root and something like this, and our bridge ID is like this. Its priority is the same as the root bridge, but its MAC address is quite different. So let's just copy this MAC address and paste it nearby our switch. So let me write its priority, and let me paste here its MAC address. And now I will take a look for the status of switch 3. Typing show spanning tree, and here we may find out that this is again information of the root bridge, but our information of this switch is this one. So we have same priority value as we have on all of the switches, and we have MAC address. So let me just type here the priority value 32769, and according to this information, I mean according to this MAC addresses, we may define that who is the root bridge. This switch is the root bridge. Why? Because it has the lower MAC address, as you see here, for 004, but here is 0001, 0007. That is why this switch is becoming the root bridge. And now let's take a look for the switch port values. Like, look, switch 2, its port FA0. So let's take a look which FA02, which is connected to switch 1, is defined as port which is root port. So let's write here root R, and this port is defined as the designated port. So it is working port. It's normal condition port. Okay, and you may see the costs are same, and you may see the priority values are same, but these values are different. And now switch 3 has one port which is equal to root port, and another port is called alternate port, and its status is blocking. So let's write here alternate. And now we may make comparison with you why this port is placed to the alternate port. Their priorities are same. I mean the bridge priorities are same, as you see here, but their MAC addresses are different, and the MAC address of switch 2 is lower than the MAC address of switch 3. That is why the port of the switch 2 FA01 is designated, and the port of the switch 3 FA01 is in FA02. Just let me take a look. Yeah, the packet tracing showing us the ports in different way, you see. So actually this port is FA02 port, and it is in blocking state. And now we have such kind of topology, and let us say that we want to have the switch 1, switch 3, it will become the root bridge, and this switch will not be a root bridge. Okay. What we need to change? We need to change the priority of the root bridge. For example, it was 32, but we will do it like 24 something, because I don't remember exact value which we can add here, so we'll just take a look from the hint of the configuration. And by the way, we'll just we'll take off this root ports, because after I will change the switch priority, I mean after I will create the switch 3 as the root bridge, everything, I mean all the ports will be recalculated, and both ports of the root bridge switches will become designated, because it is by default. And let's do it. So I have to just open the configuration of global configuration mode, and I will just write spanning tree, and afterward I will define which VLAN I am working with. By default I am working with VLAN ID number 1, and afterward I'm just saying what will be its priority. Its priority is going to be and values from 0 to this value. So and let me type, for example, 1, and it's incorrect value, and that is why Why it is incorrect value? Because it is written here that its increments, its step is 4096. So if I'll place incorrect value, it will hint me, oh, come on, you can just use only this value, and so on. So let me just change this value to 28 and 672. Oh, sorry, I have to come here, and 28 672. This value is lower than default value, which you see here. That is why our switch 3 will become the root bridge. And you see that something has to be changed. And if I'll just click to fast forward time, to skip the time, and we see that these ports are now working. And if you click to, if you'll type the command show span, you will see that 2 ports of it are designated, and now you see that the switch, this switch is the root, actually, root bridge. And now you may compare the MAC address of our own switch and MAC address of the root bridge switch are same. And now let's take a look for the root ports. I think that this switch port is root, and this switch port is root because they are closer to the root bridge now. And this port is designated port, and this port is alternate. It is alternate port because if we'll compare this value with this value, we may see that alternate port has higher MAC address than the MAC address of the designated port. So that is why it became the alternate. And even if you want, you can check this status. You see, FA02 is alternate or blocking port. So here it is. Okay. Now I will show you another method of the configuration of the spanning tree. You can also provide the configuration of the spanning tree by not by the priority, but by the command like root. And here we have 2 variants, or it's going to be the primary. It's like, okay, this switch is going to be the root, primary root. It will be root, okay. And if you type this command, okay, the switch is still the root, okay. And for example, we want to make configuration of switch 2 as the backup root. If something will be wrong with our root, then this switch will become root. And we'll just type command a spanning tree VLAN 1, which is used by default, and a root, and we can define here the secondary. Okay. And if something wrong will be, so let's alright, something is changed. So let's take a look for the spanning tree, actually. What's happened with the spanning tree? Yeah, it's saying us that its value is 28 and something. What about this value? Switch 3 do show span. Oh, it is also 28 and something. So let's take a look why it is so. So let me also, before I did it, let me change its priority to default value. Maybe this is our problem. Primary, and I don't have to write primary. I have to write priority and 32768. And I think that now everything will work properly, but oh, come on. And now let's change it again. Configure terminal and the spanning tree and VLAN 1 and priority and root primary. So approximately this switch now is the root bridge. Let's take a look for its value. Show spanning tree, Yeah, and look, when you type the command the primary, the root primary, it will give you actually the value. Just let me write here the command spanning spanning 3 VLAN 1 root primary is same as if you type command spanning 3 VLAN 1 priority and this value. So it means that root primary is same as priority 24576, and the comments which we type it here are the same. So we'll write secondary are the same as we will see from here, and this value. Copy, and now I'll just paste it here. And 2. So when you configure your switches with the root primary or root secondary, you don't have to be sure that all the time it will be the primary. It will be the root, because now if we will change our value to 4096 here, so then exactly our switch 1 will become the root bridge, because its value now will be much lower than there, but it's configured as a root primary. So enable configure terminal spanning 3 VLAN 1, and let me just change the size of this window, and we'll just write here priority is 4096. Okay, so, and now if we'll take a look for our spanning tree, we'll see that this is a root bridge. Why it is a root bridge? Because its value is much better than they have. This is how we can configure the spanning tree protocol. And now it's time to take a look how to configure a per VLAN spanning tree, which will create the different tables of the spanning tree for the different VLANs. And in this example, let me also name my switches, like a switch 10, and this switch will be called as switch 11, and the last switch will be called switch 12, like this. Alright, and our idea is to create to make switch 10 be root for VLAN 20 and switch 11 to be root for VLAN 10. And so let's take a look which ports I used here. FA01 port, which is from the left side, will be the blocking port for VLAN 10, and FA02 port will be blocking for VLAN 20. And we'll use with you per VLAN spanning tree. To be able to see that this these switches are working with the PVST protocol, you can just type the command show spanning tree. So let me show it like this, and from this oh no, we don't see it from here, so show spanning tree and detail summary. Okay, detail, so let's take a look for detail. Bad idea. Then let's take a look for a summary. And switch is in PVST mode, so we can see it here. So PVST, it's per VLAN spanning tree, and we did not configure it, but it is pre-configured by default on the Cisco switches, Catalyst 2960 switches. And also you can type command show running configuration file, which will also show you that the spanning tree which is used here is the PVST actually. And now before we'll start to do it, what we have to do, we have to configure VLANs. So we have with you VLAN 1, which is created by default. We have VLAN 10 and we have VLAN 20. Well, we have to create this VLANs on all of our switches. To create this VLANs, we are able to type the commands like we'll just open Notepad, and in Notepad we'll type the configurations which will be copied, for all switches. So we'll just create VLAN 10 and VLAN 20, and we'll say that interface range of all the switches FA01 and FA02 will be configured as the switch port mode trunk. I hope that you remember what this configuration is about, and what else we have to do. And additional configuration for switch 10 is going to be configuration of the spanning tree. Spanning tree VLAN 10 or VLAN 20 priority is going to be 4096, for example. And another configuration for S11 is spanning tree VLAN 10 priority 4096. So I will make configuration. I will just copy this field and I will make configuration of VLAN 10. I mean switch 10. So in global configuration mode, I'll just paste these configurations, and I will configure my switch switch 12. I will just copy only these values. I don't need to configure that who will have the priority values and so on. So I'll just create this VLANs on switch 12. I will just paste these configurations in global configuration mode. And the last switch which will be configured is so I'll just take it off, and this one. Also in global configuration mode, I will just paste it here. And let me fast forward time. And as you see now, look, all the ports are with the green color. But we have blocked port, we have alternate port, but they are with the green color. So what's happened? So let's take a look for the spanning tree. So if you'll now type command show span, you will see first of all spanning tree for VLAN 1 001. Okay, and this is separate table for VLAN 1. And here we have alternate port. So port FA02 is actually in blocking state of the VLAN 1, but we don't see it because the same port FA02 is working for VLAN. So let's take a look. For VLAN 10, this port FA02 is root port, but for VLAN 20, this port FA02 port is designated port, is in working state. So that is why the same port, so when you are using the PVST protocol, the same port can be used with the different port statuses. Like as you saw, for VLAN 10, the port FA02 of switch 10 is the alternate. For VLAN 1 it is alternate, for VLAN 10 it is root, and for VLAN 20 it is the designated port. And now you may take a look for a switch 12's output of the STP. So if we'll write show spanning tree, we'll also see for VLAN 10. For VLAN 10, look, where is our VLAN 10? FA01 port is actually designated. Wow. And let's take a look. And for VLAN 20, FA0, just a moment, let me take a look. So actually I expect that FA01 will be in the blocking state for VLAN 10. For VLAN 10, FA01 is designated. designated, and who is the... Let's take a look which port is blocked for VLAN 10. I think that it is port FA01. Yeah, here it is. Yeah, because in our topology we have such kind of MAC addresses that this port is blocked and this port is unblocked, FA01. Now everything is okay. And now you may see that PVST protocol is creating different tables for different VLANs. And by the way, let us also take a look for the values of the priority of the root ID. They are, so I configured, so if you'll take a look from here, I configured this value, okay, but somehow it's becoming like this, because it is plus 10, so our VLAN is 10, plus 10 for 4096 will be 41,000, I mean 4106. Okay, due to that fact that we have VLAN ID, our priority will be looking differently. Alright, and now it's time to take a look for another example where we can use with you the rapid PVST. Rapid PVST plus. Rapid PVST plus is also creating the VLANs, I mean the separate tables of the spanning tree per VLANs, but also it can work much faster than the PVST due to that fact that when you're connecting end devices to your switch port, for example, we have two end devices, and if we'll try to connect ports like this, okay, you see that this port is not working yet, so it is passing through this modes of the listening and learning states, and it's taking actually time, and after a while this link will become a green. When it will become a green, then it means that this link is properly working, and now it is, here it is, and we lost about from 40 to 50 seconds, but we want to have such kind of thing that when we are connecting to the link, this link will start to work immediately. How to do it? We have to go to configuration of the S12, and we have to say that spanning tree and mode, and we will change the mode to rapid PVST, and we have to provide this configuration on all the switches. I will just copy it and we'll configure it here also. I will paste it, and we'll paste it also here. And by the way, this switch, which switch to us, switch 12 also. Now do show span will show us that this so look, spanning tree enabled protocol is RS3. Rapid spanning tree is working here, and show run will also show you that you are working with the rapid PVST, and show span summary, which will show you that you are also working with the rapid PVST mode. And now we have to configure port FA03 on S12. Interface FA03 with the configuration of the spanning tree. And here we have the port fast. Port fast enable interface to move directly to forwarding state on link up. When link will be turned on, the port will just skip this listening and learning states and will immediately start to forward the traffic. Port fast. And when you will press enter button, you will be prompted with the warning message. Warning: the port fast should only be enabled on ports that are connected to single host, and connecting hubs and concentrators, switches or bridges to this interface when port fast is enabled can cause temporary bridging loops. Use it with caution. And afterward, we can see here that port fast has been configured on FA03, but will only have effect if man interface is on non-trunking mode. And also we are able to just define that the switch port mode will be access. It is already working, I mean the port fast, but because it is in dynamic auto state, but we'll just say that, so look, you will work only as access port switch. And now when we will connect the cable from FA0 from PC0 to FA03, it is immediately in FA03. I mean it is immediately in the forwarding state. And when you want to have not when you want to have by the way, guys, in case if you will add here not the computer but the switch, what will be happening? This command, which we typed here, the port fast spanning tree port fast on FA03, is skipping the process of the listening and learning, and is actually skipping the process of the STP. But what will be happening if we will be connected from switch 3 to switch 12? Just a moment. By using this cable, like this. So what will be happening with this link? Okay, nothing is happening, but our switch FA03 is in dangerous zone. Why it is so? Because switch 3 is sending the BPDUs, and switch 12 without listening for this BPDUs turning on this port. Okay, and what if we need to block this port or this port of the switches, but this port is not blocked because it is working with the port fast? And we may have with you the loop on layer 2, and to prevent the situation we are able to configure with the port fast. So let me write port fast has to be configured with BPDU guard function. And BPDU guard is that you already block, I mean you skip listening and learning state on the switch port, and it means that it will not work with the STP. But when BPDU frame will come to switch port, it means that something went wrong, and this this port has to be placed into the error disable, like in the port security mode, so that it will be better if you will configure your interface FA03 with the command spanning tree and BPDU guard and enabled. And now if you'll take a look for your configuration, show span summary, it will show you that you are working with the rapid PVST mode, and now this one is enabled, BPDU guard. By default, this is not enabled, but as you see here, we already have the message of the error disable. The BPDU error detected on FA03 and port is placed in error disable mode, so that you may see that now it is black. Not black, but the red. And if you will take a look for the interface FA03, you will see that the interface is placed in error disable mode. And now we can take a look how to take off the switch port FA03 from error disable mode. We have to first of all go to interface FA03 and we have to say shutdown and no shutdown, and it will start to work. But you see, after it is turned on, so let's turn it off again and turn off and turn on. After we did it, switches starting to exchange with the BPDU frames, and when BPDU frame enters to S12, S12 say, okay, I'm on port fast mode. I'm not expected to receive any BPDU frames from this port, and that is why that I'm receiving this port. I will place this port into error disable mode, and error disable mode is actually identifies that error is happening on this port. Well, let us continue our lecture. So also we have to take a look for the ports of the rapid PVST mode. We have two types of the ports. They are edge ports and non-edge ports. So edge ports are those ports which have to be configured with the port fast, and the non-edge ports they are not going to be configured with the port fast in RSTP. And also we have the link types in the rapid PVST. If our switch is connecting with so it depends only for, I mean, it impact only for the non-edge ports. Non-edge port has two types of the links. They are point-to-point, which is working the full duplex interconnectivity between switches, and shared, which is using half duplex, the interconnectivity with the hub and concentrators. And designated ports only make the most usage of the link type parameters. A rapid transition to forwarding state for the designated port occurs if only the link is placed to point-to-point state. So that if you will take a look for the status of your rapid PVST here, show span, you will see here that the type of the of your ports of FA01 and FA02 of this switch are placed to P2P. It means that these ports will be I mean, if something wrong will be happening with this link, then alternate port will be immediately be placed to the designated or to the root port status, because it is placed in type P2P. And if you will place a new device here, which will be, let's say, where's that? Which will be the hub. Which will be the hub, and and let's take a look for the port status of FA03. Hey, come on, we even don't see it here. I heard this. And here we can see that it is in shared mode, and we can see it only in VLAN 10, VLAN 1, because our port FA03 is on VLAN 1. and our port is not a trunk port. Well, let's continue. Uh, so we already passed these values. Just a moment. And now let's take a look for the STP topology change notifications. Uh, when uh, when it is used. Okay. Let's have such kind of example with you. Let me turn on my tablet. Here it is. Uh, Topology change notification. What for it is used? So imagine that we have here PC1 or PC. Okay, PC1, and PC1 has MAC address AAA, and when switch 2 is connected with PC1, and when it is learning the MAC address of the PC1, which is AAA, in the MAC address table of switch 2 there is value like AAA, and by default, after your switch has learned the MAC address, it has the aging time for the MAC address in the table by default is 300 seconds, and 300 seconds it is about not about, it is 5 minutes. So 5 minutes, switch 2 will think that it has connectivity with computer A. Okay, and when something wrong will be with this link, switch 2 has to immediately react on it and has to say to its root bridge that some changes are happening according to this MAC address, and then TCA will be sent. Though TCA is just acknowledgement. Okay, I got your message. And after this changes will be happened, uh, our MAC address table has to delete this value, because previously switch 2 knew about MAC address AAA through the port which is now not working. And afterward, switch C1 will say about these changes to all switches. Okay, so that these switches will take off value of AAA from their MAC address tables. All of them maybe knew about this MAC address AAA, and now they have to take off this information from their MAC address tables. Because if this, so if STP will not be providing such kind of functionalities like TCN, topology change notification, and TCA acknowledgement, and TC topology change, then what will be happening? Uh, let's say that we still have these values, but the computer A, PC1, sorry, with MAC address AAA is 2 minutes already not working. Okay, this port is blocked or cable is unplugged or something like this. And when switch 1 will receive the communication to AAA, it will still will redirect it to D1, and from D1 it will be redirected to S2, and afterward S2 will say, okay, come on, I don't have this value already. Now that is why we have this centralized communication between this switches, and this centralized synchronization is provided by the spanning tree protocol. And RSTP port states, we have 3 port states. They are discarding, learning, and forwarding. And in the RSTP mode, in RSTP type, or let's say in RSTP mode, we don't have this learning and listening modes. So, and due to that fact, we have faster convergence than in STP. So let's take a look for this description of the ports. The discarding. This state is seen in both state active topology and during topology synchronization and change. The discarding state prevents the forwarding of data frames, thus breaking the continually of layer 2 loop. And learning, the state is seen in both state active topology during topology synchronization and changes. The learning state accepts data frames to populate MAC table in an effort to limit flooding of unknown unicast frames. And whereas forwarding state is the seen only in stable active topologies, the forwarding switches ports determine the topology, and following topology change or during synchronization, the forwarding of data frames occurs only after proposal and agreement and process. And according the proposal and agreement, it's not covered in this lesson, so it will be covered in the future lessons. And some comparison of the STP and RSTP port states, they are like blocking is equal to discarding, listening is equal to discarding, and learning is equal to learning, and forwarding is equal to forwarding. And disabled, actually disabled is turned off functionality, I mean the turned off state of the port, administratively turned off state, and this is equal to also discarding state. And this is how you can configure rapid PVST. Actually, we already done it, and uh, I hope that this lesson been informative for you. And I'm sorry that this lesson is too long because it's covering actually much things from the redundancy of the local area network, and this is actually part 1 of the chapter 2 of routing switching book 3. And the next part is going to describe the redundancy in LAN with the routers. Like you want to exit to the internet, and when you want to exit to the internet, you can also have some redundancy from switch to the router. If you have any questions according to this lesson or any previous lessons, do not hesitate to contact me by using these email addresses.